Okay, welcome, Professor Parncutt. It's a great pleasure to host you at Institute for Philosophy and Social Theory. And I believe that you had a long day, so you had already one lecture, and thanks to our colleagues from the Faculty of Music. So we will have the pleasure to hear another aspect of your research. I have to introduce you briefly to mention that you hold your Bachelor of Sciences in Physics from the University of Melbourne and New England, both in Australia. And then your PhD is combining psychology, music, and
physics. And physics.
Physics. As I mentioned before, physics was the starting point. So practically now, with these three possible avenues, you came up after your tenure still at University of Graz, when you're teaching systematic music, you came to the topic of modeling future climate mortality, and that will be the topic of the day. But your main point, if I understood right, of your research is human impact on the climate change. So this will be, like, let's say, a brief introduction.
Yes.
So I don't want to talk more. The floor is all yours. So please, yeah. Welcome.
Thank you. So thank you to all the people out there in Zoom land for being with me. Yes, I'm interested in the human impact of climate change, and I had the impression for a long time, about 15 years, in fact, that this was not being reported properly in the literature. And I came to this topic because I was interested in human rights and anti-racism research, because I moved to Austria at the end of the last century, and I noticed that there were some problems with racism, which are the same in every country, but every time you see it happen in a different place, you kind of like, my God, they can't do that, can they? And how do we stop people being racist? And then I realized at some point that climate change was the most racist thing that you could imagine because of the human consequences, right? If you add up the consequences mathematically of what climate change will mean for people in different parts of the world, it's kind of like a colonialist, an extension of colonialism in a way. So that was how I came to this topic. And I realized that I need to be able to evaluate the damage in terms of human lives in order for people to understand how really dangerous climate change is. So the background is some things that I find very shocking, which we are confronted with quite often, but we don't really talk about. So, for example, air pollution, the consequences of air pollution, which comes mainly from combustion, from internal combustion engines and fossil fuels, causes about 7 million deaths per year. And we only know that indirectly because people get different diseases of the lungs and diseases of the heart and so on, which are then attributed theoretically to air pollution. 3 million children are dying of hunger every year. About 8 million child deaths are caused by poverty, because if the family had some money, a normal amount of money, they could have prevented the child's death. Poverty altogether costs about 20 million lives per year, in the sense that the deaths could have been avoided with some money. And so that's 1/3 of the total number of all deaths every year. As you can see on the right side, there's more than twice as many births as deaths, which is also a problem because the human population is still growing. And the expectation is that population will reach 10 billion by the end of the century, but it's still too much. And any way of reducing population growth in developing countries, which is consistent with human rights, is to be welcomed, right? So I'm not talking about terrible laws limiting the number of children to 1 per family, but other stuff like, I wrote down here somewhere, I didn't write it down. So improving education, reducing poverty, informing about the use of contraception, and women's rights mainly, right? These are the best ways to reduce birth rate. These things are not reported in the media. When we get shocked in the media because people are dying, so for example, in the Gaza Strip or in Ukraine, we are confronted with numbers like thousands of people, right? And these numbers are 1,000 times bigger, and we don't even talk about it, right? And so I would like to steer the focus towards the biggest problems. So this is one reason why I would like to predict future death rates. If this was a philosophy talk, people would talk about the history of philosophy of morality. I don't know much about that, but I think it's obvious. We consider it self-evident, as it says in the start of the US Constitution. It seems self-evident that we have a moral obligation to promote good things, freedom, happiness, and well-being, and that we can reduce that. We can do that best by reducing suffering. Right? You can try to make people happy, but actually, people should be free to be as happy as they want. But we have an obligation to reduce suffering, and there's also something about value. Like if a beautiful church burns, everyone is shocked because of the value of the church, right? And so there's something about value which we need to evaluate. And my assumption is that the foundation of human value is the value of a human life. And we intuitively measure value relative to that fundamental unit of value. And there's another assumption here, and that is if there's a big disaster, for example, there's an earthquake or there's a tornado or a ship is sinking or something, there is loss of life, and there's also suffering by those who die and suffering by those who don't die, right? And if our philosophy is to minimize suffering, we can look at the number of people who die and take that as a measure of the suffering, because that's approximately proportional, right? So this is what this symbol is, approximately proportional to the number of deaths. So in this talk today, I'm just going to talk about the number of deaths as my main measure. And of course, a death is worse if someone dies younger because they lose a greater number of years of life, right? One approach to this topic is to add up the number of years of healthy life that a person loses when they die. And I'm not going to do that today because it's a bit hard to understand the numbers. If I give you a number, say this many years of life have been lost and so many millions or something, it doesn't really make much sense. And I prefer to talk about the number of premature deaths and then say the assumption is that the person died at an average age. Perhaps they were very young, perhaps they were very old. More likely in the case of climate change, they were either very young or very old because those people are more vulnerable. But they could also have died in the middle. And then we could say, oh, the average number of life years lost by a person who dies in the consequence of climate change is maybe 30 or 40 years. So I'm going to talk about the number of preventable deaths, and I'm also going to say the importance of an issue depends on the preventability. The amount of attention we give to an issue depends on our power to actually change the situation, right? So we should actually focus on things that we can change, and they are the preventable things. So I mentioned this, the most important causes of death, like the children dying of hunger and so on, are hardly in the media, and the media show things that are 1,000 times less important as if they were 1,000 more times important. So we need to reach the people by some other means, and that's a very difficult problem, and I can't actually answer that question. So you see, the aim is to save millions of lives because it's a rational approach to promoting well-being. We have to talk about climate change, communication, human security is also involved, and economics. And I'll talk about this at the end again, but if you think in this kind of logical, rational way, what is the most effective way to save the largest number of lives in the future? Climate litigation is a very promising way. That means taking people to court and prosecuting them for causing large numbers of deaths in the future. And you can only do that if you have a good scientific estimate of the number of people whose lives have been shortened, and you need to have some scientific consensus. And so this is why I'm trying to get other people interested in this issue. So before criticizing fossil fuels, it's important to realize that they are the reason why we have such prosperity. The benefits from fossil fuels are enormous. Life expectancy is increased in just 1.5 centuries, or will have increased by the end of this century by almost a factor of 2. This is extraordinary. People used to live until they were 40 or 50, and now they live until they're 80 or 90. And of course, there are many reasons for that, but fossil fuels is a very positive influence. And if you see supermarkets full of stuff and people can eat what they want, and people have good medical care, and people have good transport, these things are related to fossil fuels. So fossil fuels in themselves are not bad. And the problem is, of course, that the temperature is going up. And I like to show this graph because everyone knows that the temperature is going up. But and everyone knows the main solution is to stop emitting carbon dioxide. But strangely enough, we have a lot of people all over the world still inventing creative reasons why this is not obvious. But of course it is obvious, right? Yes, I won't go on about it. The obvious thing that has to happen is to stop emitting, and that means leaving fossil fuels in the ground, not even extracting them, because as soon as they are extracted, they're going to be burned sometime. We also have the COP series, which has been a dismal failure, although an enormous number of issues have been discussed, right? I mean, there has been some positive effect, but basically all of the goals of the COP series for the last 28 years or something have not been reached. And the goal of global net zero by mid-century is still looking very unlikely at the rate we are going. So part of my aim is to wake people up to how serious that is. So a couple of years ago, I wrote this paper, and I was glad to have it published in the journal Frontiers in Psychology, although it's not exactly about psychology. It's kind of across many different academic disciplines. And the point of this paper is that you can burn a certain amount of carbon and cause the death of a person in the future. And that number is 1,000 tons of carbon. So if you imagine what a ton of carbon looks like, a ton of water is 1 cubic meter, so you know it's this big, and a ton of carbon is a little bit bigger, and so you could have this big pile of carbon in the middle of this room, which would be 1,000 tons of carbon. If you burn all of that, a person in the future is being killed. And it's very easy to explain where that number comes from, and in my opinion, it's very difficult to explain why that could be wrong. For me, it's like so obvious, like the sky is blue, but for some reason, nobody wants to talk about it. So, and then I met this guy called Joshua Pearce who wrote to me and said, oh, I like your paper about the 1,000 ton rule. Can we write a paper on that? And he is an engineer, and he is working on all kinds of alternative energy solutions like more efficient solar cells, or I have no idea, heating systems and so on. And so he became the first author of a paper where we tried to explain again why the 1,000 ton rule is an important idea. And my other hypothesis that 2 degrees Celsius of global warming will cause the premature deaths of 1 billion people over the next 2 centuries. We also talked about how that can be justified. So given this background, my aim is to predict future mortality more precisely. And I should tell you in advance that I have not achieved that aim. But the scientific community wants something more precise. And there's a tradition in scientific journals that you state the uncertainty in your numbers and you try to do that precisely. And of course, in this case, it's very difficult. I want to compare different approaches to calculating future mortality in order to get what we call convergent evidence. On the basis of different assumptions, hopefully coming towards a similar conclusion. All right. So let's just talk about the value of human lives. And I already introduced it briefly. So according to effective altruism, which I found a quite inspiring approach, the project of using evidence and reason to figure out how to benefit others as much as possible and taking action on that basis. Its aims are welfarist, impartial, maximising, effective altruists aim to maximise the well-being of all, where everyone counts for one and no one for more than one. So that's one way of describing effective altruism. This is exactly what I want to do, right? So if every person thinks we have an obligation to somehow help other people and we should try to maximize the positive effect for a certain amount of effort, and we're only going to do it for part of the week or a few hours a week because we have to look after ourselves and everything else, right? So we come to this idea of effective altruism. Effectiveness is value divided by effort. We can try rationally to find how to get the greatest value by using the smallest amount of effort, and then we will have the biggest success. So we could also apply this idea to research in general in any academic discipline. People talk about important research and they imply that research has value. And I've already told you my claim, the foundation of human value is the value of a human life, right? And if you agree with that, of course, non-human lives are also important, but they tend to be regarded relative to human lives. That's another long story, but and I've also used the word conscious human life because, unfortunately, in the background of this discussion is the abortion debate, right? And I would assume that the fetus is not conscious, and consciousness is something that develops during infancy and childhood in interaction with caregivers. And a conscious human is a member of society, right? And this is the morality that I would like to propose. We have an obligation towards conscious members of society with whom we communicate and with whom we share experience and values, right? So the most important application of research should be then to save large numbers of conscious human lives and to minimize avoidable death rates. I think I should say, so I'm a musicologist, right? So I'm very interested in music, and that's nothing to do with saving lives. It's about improving the quality of life of people, which is intended to be included in this, right? I mean, if human lives have value, they should be rich human lives that are full of culture and diversity and stuff, right? And so the arts belong to that. The the Universal Declaration of Human Rights from the year 1948 is a great source of statements about human equality, saying that every human is equal regardless of all this other stuff, right? So equal before the law, regardless of male or female, and regardless of black or white or disabled or not disabled or young or old and everything. But so this is also a basic assumption that the unit, one human life, is independent of all kinds of features or attributes of people. So we could even compare the value of a human life with physical measurements, which in classical physics are meters, kilograms, and seconds. Some people seem to think that the unit of value is the American dollar, and there is some justification of that. But I think the academic discipline of economics goes a bit too far in regarding the dollar as the unit of value. There's even attempts to evaluate the human life in dollars, which is like one human life is $100,000, because that's the amount of money that someone might pay in order to save their life. And that amount of money, of course, depends what country you're living in. But I think if we consider that example, we can also be open to the idea that actually the value of a human life is more fundamental than the value of a dollar at a different level. All right, and so if you look at ethics and religion and law, you see ideas which are consistent with the importance of the value of a human life. So now the next question is, why do I focus on global warming and not some other risk? Well, we can make a list of existential risks, and we can try to evaluate the size of the risk by looking at the damage that would happen and the probability of that damage happening. So in the case of nuclear war, we could say there's a threat which is bigger if there is a larger number of missiles, and if the missiles have more power, and also if there's more instability which could lead to a nuclear conflict or the probability of an accident, right? Somehow we could evaluate mathematically the danger of nuclear war. In the case of biodiversity loss, we could look at the number of lost species and we could estimate the value of those species for humans if we take a completely human-centric approach. Now, actually, I don't agree with a human-centered approach, but I also realize that politically it's the most likely approach to be successful, right? If I want to stop biodiversity loss and I argue about the benefits of biodiversity for humans, I'm more likely to succeed. So that's why I talk about value for humans. Poverty, the danger of poverty is the amount of suffering from poverty. Plutocracy is because the rich are getting richer and the poor are getting smaller. How dangerous is that? Well, I'm assuming for the purpose of this talk that global warming is a bigger threat than all of the other things. And the reason is that it's actually happening. The probability of it happening is like 100%, and the other ones have a smaller probability. So here's an example to show you how probability affects our assessment of risk. Perhaps you know there's some standard definition of risk, which is the harm done multiplied by the probability. Let's take a bridge like Sydney Harbour Bridge over there on the left-hand side. Let's say we're going to build this bridge and we want to evaluate the risk, right? So what could happen is the bridge could fall down, and when it falls down, 100 people might die. Order of magnitude estimate, and the probability of the bridge falling down is probably 1 in 1,000, because you can look at all the bridges in the world and see how many of them fell down, right? And if you multiply that together, you find out the risk is 1 over 10. That means, well, by building this bridge, I'm effectively killing 1/10 of a person, or I'm effectively stealing 1/10 of the life of a person. And I think that's okay because of the enormous benefits of that bridge. Millions of people going across every year, right? So that person who dies as a result of building the bridge, or the fraction, is really quite small compared to the benefit. So it's okay. Now, if you build a nuclear power plant, it's not so okay, because if there was a really serious problem with the nuclear power plant, 1 million people could die because of the radiation and all of the cancers that would happen and so on. And maybe that happened with Chernobyl. We're not really sure how many people were killed from Chernobyl. And the probability is probably about 1 in 1,000 again. So we effectively kill 1,000 people according to this very rough estimate when we build a nuclear power plant. And so according to my calculation, we should never build nuclear power plants, because that cannot possibly be justified, right? Now, as for global warming, we could kill a billion people, a large proportion of the human population, and it's happening with a probability of at least 10%. This is a very conservative estimate. And when you multiply that together, you get an absolutely enormous risk. It's this, you cannot imagine a bigger risk than that. This is why I'm focusing on it, right? Because both the harm and the probability are so big. Okay, so now the next thing I want to talk about is a death taboo, the reluctance of people to talk about death. So this is partly because death is a very difficult thing to understand. We have religion in order to help us understand death, but actually, fundamentally, there's something about death that really we cannot possibly understand, right? I mean, the fact that I will not exist one day is really impossible for me to comprehend. But another thing about death is that I could be causing someone else's death, and I don't want you to know that. So this is... Let's take the internet, the IPCC. They started talking about reasons for concern in the latest report. And I think this is a great development, because it's actually focusing the philosophical aspect of this problem. And you will notice in those 5 points, which are all, of course, very important, they never mentioned human deaths. And my claim would be, well, human deaths should be right on the top of the list. Why did they not do that? Is it unscientific to talk about human deaths? In fact, they did talk quite a lot indirectly about human deaths in the report, and here are some examples. So at the top, 3.3 to 3.6 billion people live in contexts that are highly vulnerable. So the implication is that their lives are at risk, and that a certain proportion of them will die prematurely as a result. But it doesn't say that directly. And all of those other statements are about mortality. So, for example, yes, there are some places where the risk of death is much higher than in other places, and so on. A livable future for all is a future that you can live in, and if the future is not livable, then obviously many people will die prematurely. Okay, so what are those numbers that people are avoiding? Oh, it goes on. There's even more statements. Heat-related mortality. Yes, vector-borne diseases, flooding, biodiversity loss, decrease in food production, implying that more people will die of hunger, severe consequences for people, implying that many will die, and so on. So there's a tendency to talk about physics and economics in terms of numbers and say these are real hard numbers, but when it comes to human deaths, there's a tendency to be, oh, I'm not really sure. Now, this is the other extreme. The science warning series is very interesting. People from many different areas of science relevant for climate change are publishing papers called Science Warning. And Bill Ripple is the guy who's doing this. And in this paper, it looks exaggerated, but actually it's very carefully stated. So could threaten the lives of up to 6 billion people means that a certain proportion of those will die prematurely. As many as 6 billion people could find themselves in regions that are no longer habitable, which means they have to move, they become climate migrants, and a certain proportion of them will die prematurely, right? So what are the causes of death? In order to estimate the number of people who will die, we need to go through the causes of death and try to estimate each cause, and also remember that those causes will interact because often there's more than one cause of death. So here's a list of the ways in which people will die as an indirect consequence of climate change. These can be called the proximal causes because they're more like the direct causes, and the distal cause or the less direct cause is climate change itself. So there are individual causes, which means that my basic needs are not being fulfilled. There are social causes, which means a large group of people are having a problem. And then there are so-called natural causes, which are in fact unnatural because human-caused climate change is unnatural. So starting with the individual causes, disease is going to kill a lot of people because existing diseases will move from one geographic area to another area where people have less resistance. And also, so for example, malaria coming to the south of Italy would be an example of that. Starvation is because there won't be enough food and because the distribution will not improve and it perhaps will become worse. Humid heat is a big deal. If the temperature of your skin approaches, sorry, if the wet bulb temperature approaches the temperature of your skin, then you cannot cool yourself anymore. It's physically impossible to cool yourself. So wet bulb temperature is when you put a wet rag around the thermometer, and it's as if there was 100% humidity. And at wet bulb temperature above 35 degrees is then normally considered fatal for anybody within a few hours, right? And it has hardly, so far in history, it has hardly ever happened, but it will happen more frequently. Wildfire smoke is a big one because, as you noticed at the start of this talk, air pollution is a big killer even without climate change, and wildfire smoke, like it happened recently in Canada and in Greece and so on, in Australia, can become more intense, and people die from diseases indirectly and later from this. Social causes are conflicts. For example, the classic case, water wars. So when one river is being used by many people and the water gets less and they start to have conflicts. Migration, of course, when an area of the planet becomes uninhabitable, then millions of people will have to move and they will be called climate migrants. And there, of course, are already a lot of people who are really climate migrants. Precipitation, floods and storms is an obvious one. And the geology is maybe not so obvious. A lot of people don't realize that the probability of earthquakes is going up because of climate change. And I'll show you that on the next slide. Geophysical disasters. They tend to have a high death toll, but they happen with a low probability. And so you multiply that number together to get the risk. So you remember in 2004 that 200,000 people died from a tsunami in Indonesia. This is much more than the disasters we normally think of. So we are so terribly shocked that 30,000 people were killed in Gaza, right? And this is here already 6 times more. Earthquake in Hawaii, 200,000 people died. And even just in the year 2022, due to all the different earthquakes and tsunamis, there were 700,000 people who had to move somewhere. And so obviously some of those died prematurely. There's a lot of danger from earthquakes, and here's the reason down the bottom of the slide. the changing mass of water near fault lines. So earthquakes are caused when the plates of the earth are going up and down next to each other, and when there's any change of the mass on those plates, that increases the chance of an earthquake. And so when the glaciers melt, there's less mass on the mountain, and when the sea level rises, there's more mass on, right? So you can see how that would work. All right. There's a lot of literature on this that most people don't know about. So I just wanted to show you that it exists. Now, I promised you to explain the 1,000-ton rule. The 1,000-ton rule says that if you burn 1,000 tons of carbon, fossil carbon now, you will cause the death of one person in the future. And the reason for that is that if humanity continues burning carbon so that the total of all carbon burned since the start of the Industrial Revolution is 1 trillion tons, which is 10 to the power 9, then that will cause global warming of 2 degrees Celsius. And according to my estimate, which I'm going to show you, that will cause 1 billion premature deaths over a very long period, 1 or 2 centuries. And that means that if we burn 1,000 tons of carbon, we cause 1 premature death. And so that means that any large fossil fuel project which is causing thousands of tons to be burnt is causing future deaths, and the ones that are causing millions of tons to be burned are causing thousands of deaths. And we can actually estimate that, and it's relatively straightforward. So let me tell you how I came up with this number. We can't predict the future, right? We don't know what's going to happen, but we know we can imagine many different scenarios. So I wrote down on the left-hand side some things that could drastically change the future mortality from climate change. The American presidential candidate suddenly dies, right? So suddenly either Trump or the other guy gets in and it changes the international policy. Or there's some amazing new discovery in science to get rid of carbon dioxide, completely changes the effect, right? It's possible. Other such things, right? And so the point of this is that the lower limit, so it could be possible that actually no one dies at all because suddenly the problem gets solved, but this is so very unlikely, it's crazy, right? And on the other end, the number of people who die could be infinite. Now, it can't be infinite because the maximum is 10 billion, which is the predicted future human population. But I'm going to talk about global warming of 2 degrees, and I'm assuming that the number of people who die in that scenario is much smaller than the human population, and therefore it's effectively infinite. And for that reason, I'm using this thing called a log normal distribution to model in a first approximation the distribution of predicted numbers of deaths. This graph is also a log normal distribution because the horizontal axis is logarithmic. So it looks symmetrical, but the axis is logarithmic. And so I'm assuming that our prediction of the total number of deaths is a broad distribution like this because we're quite unsure about it, plus or minus 30% or something like this. It's like an order of magnitude. And we can talk about the best case and the worst case. And now I would like to talk about those 5 boxes. The very best case is that the current level of deaths from global warming continues at the same rate for a century. A century is also an order of magnitude, right? And the current rate I'm going to explain to you in the next few slides is approximately 1 million people per year. People don't know this, and I'll talk to you about it, okay? So if 1 million people per year kept dying from climate change for 100 years, we would have 100 million, and that would be the left side of the graph. It's very unlikely. And the very worst case is that the whole human population dies from 2 degrees, and that could happen if there's a sequence of tipping points crossed and the tipping points interact with each other and a completely unprecedented global catastrophe happens. It's very, very unlikely. So I'm putting it down here, right? And there's also a worst case, which would be 300 million people dying, and then there's, 3 billion people dying over a long period, and a very best case, which is 300 million. And I have some comparisons to make about that. So you see, so the best case would be like the number of people dying from global warming is approximately equal to the number of children dying of hunger. So you can imagine the number of children dying from hunger being doubled. And that is the best case because there's so many other causes of death, right? And the worst case would be like the current death rate from poverty, all causes doubling, like twice as many people being killed from poverty. I'm estimating the death rate from poverty at 20 million per year, not 30 per year. But so anyway, by making these kinds of vague comparisons, we can get a feeling for the size of the numbers. And so what I'm doing is somewhere between science and humanities. I'm trying to get evidence and ideas from different sources and compare them with each other. And it's a bit like the hermeneutic spiral. Perhaps you know this idea. You start with a vague idea, and then you look at sources of evidence from different places, and you get gradually a more exact idea to solve your problem. I think scientists often do that, but humanities scholars are the ones who actually talk about this process. Okay, so here's an example which convinces me that my estimate could be conservative. So when I say climate change of 2 degrees will cause 1 billion deaths in the future, I actually think it's a little bit conservative. It's probably going to be a bit more than that. And one reason is if you look at the situation in Africa, according to current predictions about population growth, the population should grow from 1.4 billion now to about 4 billion in 2100. And that's because there are some countries in Africa where the population growth is still very high, in Nigeria, for example. And it's very hard to slow that down because if the population growth is happening already now, it's having effects decades into the future. So if that's true, it's quite clear that agriculture cannot keep up with that, because at the same time as the population grows, then the water and soil and biodiversity are going downhill. So the ability to produce food probably will go downhill, although there's always some technological developments which can improve the ability to produce food. Perhaps you know that the reason why that the number of people dying of hunger has been going down gradually for the last few decades, and that is partly because of new technologies to produce food more efficiently, and that partly is involving insecticides and fertilizers. And both of those things are actually having long-term bad consequences. So they give a short-term good consequence for better productivity, but in the long term, we get degradation of soil and loss of biodiversity, which means that the food supply in the future would be worse. Right? So because of that, we can imagine by 2100, 1 billion people dying prematurely only in Africa, right? And my estimate is actually for the whole world 1 billion, which I think it could be a bit conservative. A good scientist is always a bit conservative, apparently. Anyway, so here is India. The population is currently 1.4 billion, which is the same as China. And the population growth is much smaller. And the expected population in 2100 is about 1.6 billion. But there's still expectations of the death rate rising because of problems with producing the amount of food. So I found an interesting paper from the year 2020, which talked about the changing precipitation. So the timing of the monsoon every year has been changing in the last few years and will continue to change, and that affects the agriculture. Groundwater is diminishing, water from glaciers. There's I don't know how many people, 1 billion people in the world depend on water from the glaciers, from the Himalayas, right? And the glaciers are gradually melting. And so we're in a period now when sometimes there's even more water than there used to be because of the melting glaciers. But in the future, when the glaciers disappear, there could be much less water. And this will happen this century, right? So, and then there's the probability of humid heat events, which is relatively high in the north part of India, that high humidity will be combined with high temperatures. And then if people have no air conditioning or no way of cooling themselves, they could die in very large numbers from that effect. So this guy, Tim Lenton, is concerned about this question, and he talked about something called the human climate niche, which is the place where humans can survive. So the range of temperatures and other atmospheric things like humidity where people can normally survive. And he predicted that so many people will be outside of this safe area at the end of the century. So by 2100, with 2.7 degrees of global warming, he calculated or predicted that 1/3 of all people in the world, which would be 3 billion people by then, will be outside of this safe area. So they will have to move or they die, right? Or unless they all get air conditioning, right? Which is another option. So a lot of people will get air conditioning and they will have an environmentally friendly way of running the air conditioning, right? But I believe a majority of people will not have that, and so they will become climate refugees, and a certain proportion of those people will die prematurely. And if we assume that there will be, that half of those people would die prematurely, not immediately, but over a certain period of time, that would be 1.5 billion deaths at 2.7, which is consistent with my estimate of 1 billion deaths from climate change at 2 degrees. Daniel Bresser is another interesting paper. This paper is also about deaths from climate change, but it focuses on heat, not necessarily humid heat, but simply extreme heat. And he used integrated assessment models, which is a concept from climate science where climate scientists say, well, climate is not only the physical interaction of the Earth's atmosphere and the oceans and the forests, right? Climate change is also the interaction of human beings with the atmosphere and how societies deal with it. And economists are talking about human society, and they try to quantify those things into one model. I don't know the details. It's quite complex, and I couldn't read the paper very well, but I'm interested in the conclusion, where this guy, Daniel Bresser, said that adding 4,000 tonnes of carbon dioxide causes one excess death, and 4,000 tonnes of carbon dioxide 4,400 corresponds to burning 1,200 tonnes of carbon, because if you burn 1 tonne of carbon, you make 3.7 tonnes of carbon dioxide, right? That's a bit of chemistry, and that's consistent with the 1,000-tonne rule. So the 1,000-tonne rule is a bit more serious, but in this article, he considered only one kind of death from climate change, only heat, direct heat, and there are many other ways that climate change can kill. He only considered the 21st century, but obviously there will be effects. The cause of deaths in the 20th century is happening now because of the time that CO2 stays in the atmosphere. He never considered humidity. So I think that the literature is consistent with my claim. And so another interesting point about the 1,000-tonne rule is that it only applies up to warming of 2 degrees. Right now we're coming close to 1.5. If the warming keeps going up to 3, 4, 5 degrees, the situation gets worse. The amount of carbon that you will need to burn to kill a future person will become less as the temperature goes up. And you can see that from this graph. I should explain some basic assumptions. There's an estimate that if all of the available carbon in the Earth's crust was burnt, it's much more than we have burnt so far, and some of it's not so accessible. If all of that was burned, it would be about 5 trillion tonnes, and that would cause about, very roughly, 10 degrees Celsius of warming. And that would cause human extinction because, let me see, it's just a rough estimate, right? But 5 tonnes, according to this source, Hood 2116, they said that the effect of burning all that carbon would cause would cause warming of between 6 and 9 degrees. But if you add the effect of methane, most of these studies don't include everything, right? So this particular study just completely forgot about the methane coming from the permafrost, right? If you add that, probably that means going up to 10 degrees. Anyway, what I want to tell you is I'm assuming that 10 degrees is extinction for humanity, unless a small minority has some amazing technology to stay alive. But to run that technology, you need people, right? And probably that won't be possible. So that's what the graph is going to look like. It kind of curves upward a bit. what does the implication, what's the implication of the 1,000 tonne rule? It says every bit of carbon burning causes future warming, and every bit of future warming causes human deaths in the future on average. Therefore, no matter how good or how bad the progress that we have in the next 10, 20, 30 years, every bit of carbon counts, right? So every bit of carbon that you can prevent from being burned is counting. 1 billion lives is lost every time we go another degree C above 2 degrees, very roughly, right? That means that every time we prevent 0.01 degrees of warming, we save 1 million lives. And when we prevent 1/1,000,000th of a degree of warming, we save 1,000 lives. So this is an important task. Here is one of the biggest coal mines in the world, and it's in Australia. It's being pushed by Adani, who's an Indian guy with a lot of money, and it's, if all of that coal is mined, it's absolutely catastrophic. It's way beyond what we can imagine. Would cause 8 million deaths according to the 1,000 tonne rule. Of course, it has to stop immediately. Personal implications. So an upper middle class person in a rich country is typically burning 1,000 tonnes of carbon in their lifetime. So they're causing the death of one future person. But rich people, right, you know, like the proper rich, you know, the ones with the private jets and so on, they can easily be causing 100 or 1,000 deaths in the future with their emissions. And people who are involved in the fossil fuel industry, who are pushing fossil fuels in, you know, the worst ones, right, they could be causing 1 million deaths. You can calculate using this rule how many deaths one person could cause. So that's one point which probably doesn't apply to people in this room, but on the right-hand side is what does apply to us. If you burn 1.3 tonnes of carbon, you can take an intercontinental return flight, which I've done many times in my life because I come from Australia and I flew back and forth from Australia to Europe, and every time I burned at least that much carbon, and I took time away from the future person's life, right? And I did this over the last few decades, and all of that CO2 that was produced on my behalf is still in the atmosphere, and it will still have this effect in the future, taking time away from future people. So I don't think it's very easy to justify that. And that being the case, it should be easy to convince people not to fly in aeroplanes. Wouldn't that be good? Now, the next thing I want to do, what time is it? It's after 7 o'clock. I've got to stop soon. I'm trying to estimate these numbers, right? And I need different approaches to making those estimates. And I try to show they converge on the same result. So in this case, I'm going to try and look at how the death rate could increase gradually in the next few decades and whether that is consistent with my estimate. So this whole research project is based on a linear estimate, which is very common in climate change. The effect of burning carbon on the Earth's temperature is in fact non-linear in many different ways, in rather complex ways, but since I can only do an order of magnitude estimate, I find the simplest mathematics I can. And that is this linear estimate, which says that as you burn carbon, the temperature goes up in proportion. The temperature increase is proportional to the amount of carbon. So if we burn 1 trillion tonnes of carbon, the temperature goes up by 2 degrees. If we burn 2 trillion tonnes, which is approximately doubling the amount of CO2 in the atmosphere, the temperature goes up by 4 degrees. Now, there are other physical models which tell you something else. But the physical models, the simple physical models, are not including the absorption of CO2. So the thing that makes this complicated is that the CO2 is absorbed by the ocean and by the forests, right? And that reduces the rate of warming. But there's a limit to how much the CO2, how much the ocean can absorb. And so that means in the future, the absorption might change. So it's all quite complicated. And this is just an approximation. All right. The IPCC published these well-known curves talking about how the temperature will increase across the next century. And I'm focusing on 2 degrees. I'm a bit naive about this. I'm going to expect, for the purpose of argument, that humanity suddenly manages to limit warming to 2 degrees. Most climate scientists in the world believe that we will go for 2.5 degrees. There was a survey recently. So, and you can imagine a linear approximation to these things. And that's only this century, right? For the next century, we also have predictions from the IPCC which say that it could be possible to stabilize the temperature at close to 2 degrees in the 22nd century. Now, actually, the estimates I'm going to show will assume that the temperature goes down gradually in the 22nd century. And so I'm kind of being conservative about that as well. So here is a way of understanding my approach to estimating the temporal development of climate change. On the horizontal axis is the year, and it goes from 2000 to 2100, so that's the 21st century. And on the vertical axis, it says global preventable death rate due to poverty. So if we assume that the number of people who die per year due to poverty is currently 20 million, which means that if those people had a reasonable amount of money, they would find ways not to die. So they would cure their disease, they would get food and so on. We can compare 2 cases. One case is with global warming and one is without global warming. So let's just imagine that the deniers are right. There is no global warming. And in the last few decades, things have been improving gradually. Every decade, the amount of the death rate in connection with poverty has been going down in the last few decades. It only stopped going down in about 2015, actually, and is now gradually going up. So the line on the bottom of the graph is what would happen if we had no global warming. Things would gradually get better and the death rate would go down. But in fact, what I expect to happen, and everybody else, is that the death rate will gradually go up. And that's the top line. And the number of deaths which can be attributed to global warming is the area of that space between the 2 lines. And the area of that space is 500 million. It's just a simple area of a triangle. So I'm assuming that there will be very approximately 500 million deaths in this century from this kind of effect, and then another 500 million in the following century, resulting from the emissions that we are producing now, right? And after that, our responsibility goes away, because our responsibility goes for the duration of carbon dioxide in the atmosphere. Oops, sorry about that. Yes, that's better. So what is the duration of global warming? The duration is the duration of carbon dioxide staying in the atmosphere. And according to the literature, there's a half-life and there's a duration. This is just a little bit of mathematics. So the half-life is about 120 years, which is the time it takes for the concentration to go down to half its previous value, because the oceans and the forests are absorbing it. And but the average half-life is a bit longer because there's a ratio of E/2, which I don't have to tell you about. Okay, so we could say that the average half-life is 160 years. And then I could say, all right, if carbon emissions are going to cause 1 billion deaths, that could be 6 million per year on average for a total of 160 years. That's one way of looking at it. And 6 million per year is actually not very many, because you see that's less than the number currently dying from air pollution. So a very simple approximation could look like this. The number of people dying per year is going to go gradually up until the end of the century, and then it's going to come down again. And we are over here at 2024, where the current rate is about 1 million per year, and it's going to keep going up to 10 million and then come down again, because by some miracle, we're going to completely stop emitting, according to this assumption. And actually, it's not going to be a triangle. It will be a kind of curve like this. This is the next stage of approximation. Just fit the standard bell-shaped curve to my prediction. So right now, it's about 1 million. It's going to go up. Maybe it will reach a peak at 2120, and the area under the curve is 1 billion deaths, although the maximum of this curve is about 8 million, because I've smoothed over the top. You may doubt that the current death rate is really 1 million, but there are several estimates about the current death rate in connection with global warming, which do not include all of the numbers. Either they only talk about some causes of death, or they don't worry about the missing data, right? Of course, we don't have all the data about people dying, and so you have to guess how big the missing data is. I fear that I'm going such a long time. I have to stop soon. Sorry. So underestimation is a big deal. I want to have a good way of talking about underestimation to estimate what the real numbers are. So I made a long list of the different ways that these numbers could be underestimated. There is some literature about how the IPCC and science generally has been slightly underestimating effects of all kinds in connection with climate change, which is part of the conservatism of science and is a respectable thing, I think. Secondly, there's something called committed warming, which is going to happen even if all of the emissions suddenly stop. And it's usually underestimated or completely ignored. So, for example, when the air pollution goes away, there's going to be global warming because the air pollution is preventing global warming. That's one example. The third point, focusing on selected cause of death. Almost all the literature I've read has not covered all of the causes of death from global warming. So some people talk about humid heat, some people talk about starvation, other people talk about disease, and it's very hard to find someone who's talking about all of that stuff. Missing data, of course we don't know. I mean, the medical authorities of the world only have access to a certain part of the data. Failure to quantify low probability, high risk scenarios. So we know, for example, there could be some kind of coupling of tipping points leading to some unpredictably large disaster. People normally don't even mention that because they have no idea about it. So they just leave it out, right? I try to include it on my bell-shaped curve, which includes the probability of different things. Failure to consider qualitative data or humanities ideas. There's a focus on scientific as opposed to humanities approaches. Focus on bottom-up extrapolation rather than top-down comparison. So bottom-up extrapolation is like, we know how many people are dying from climate change now, and we think it's going to increase like this, and therefore the prediction is this. But in fact, climate change is going to involve death rates of many different kinds going up. And you have to look at how they behave by themselves. And this is what I mean by a top-down. Vested interests of researchers. I fly in aeroplanes, so I should not tell you this story. Psychological biases, there are many of them. So there's also overestimation. So you're listening to this talk and feeling very bad and hating it and wishing you never came to this talk because it's so bad. And therefore, it's natural to think this is really bad and therefore we're going to exaggerate. And there's a lot of examples of exaggeration. We have to avoid that too. All right, I don't want to go, I have no time to go through all this, I'm sorry. There are conservative IPCC predictions. There's underestimation of the natural inertia of the climate system. Oh, I have to go through this. Focus on selected causes of death. This guy here, John Broome, he's great. He wrote some really good papers, but I unfortunately have to criticize him because he did the classic things that I'm talking about, underestimating the number of causes of death. So he writes this sentence when he talks about droughts, floods, and storms, and diseases, and poverty. And of course, you're very shocked when you read this sentence, but when you think again, you realize that he forgot to mention humid heat, and he forgot to mention starvation, which are probably the main causes of death in the future. Okay, I'm going to skip over a whole lot of stuff here. The main causes of death now, if you look in the literature, you find out that they're all going to increase because of climate change. Long story. This table, okay. So in this table, I try to estimate the death rate in the future from different causes of death. And I'm doing what I call a top-down estimation. I start with the current death rate from different causes, and I try to predict what will happen when climate change increases those death rates. So the blue numbers are current death rates. Currently, we have diseases people are dying of diseases which could be sensitive to global warming in the future, but without global warming, 25 million. It says 25,000, but you multiply by 1,000. So 25 million people per year are dying from diseases which are vulnerable to climate change. 700,000 people are dying from some kind of heat extremes per year. About 8 million from air pollution. I said 7 million before. There's different estimates. About 500,000 from conflict, so military and civilian deaths. About 9,000 from migration, 60,000 from floods and storms and cyclones and so precipitation, about 40 from landslides and earthquakes and tsunamis, 40,000. And I've tried to estimate the effect of climate change. So these numbers are caused by climate change, and these ones are actually not caused by climate change. These ones, the existing ones, correspond to that point. And if you try to make this analysis very approximately, it's more or less consistent with the idea that 1 billion deaths are caused by 2 degrees of climate change and 3 billion by 4 degrees. So the idea that every degree of climate change above 2 degrees causes roughly 1 billion further deaths. Air pollution here is mainly from wildfires. Pollution is very badly, air pollution is very bad for you. Okay, so I have to stop soon. So implications, human rights and equality are very important, especially because they're threatened by climate change, and we should be have the courage to state the facts about the deaths which were caused by burning carbon. There should be more research on this topic because I don't know what I'm talking about. I'm just a musicologist. I mean, I have no right to make these claims. I want other people to do it and to do it carefully. There should be journals and there should be professorships in this topic. You know, this is like human survival. We should talk about these things directly. We should not avoid using the word death. If we're and killing, if we're actually causing the death of someone, we're killing them, right? And this is the English word for that. And also, we should try not to panic because there's a tendency to think, oh, that's far too big. But we have to kind of rationally look at the situation and say, let's be an effective altruist and find the best way of doing it. So I promised in the title of this talk to talk about ethics, human security and climate litigation. Clearly, we have a new kind of ethics in the 21st century and it needs to be explored. The difference is that we're approaching the ecological limits of the planet and that never happened before. And because of that, we have a totally new idea. For example, not flying is completely new compared to any previous ethical code, right? I'm interested in Kant's categorical imperative, which we could talk about another time. So human security is another very important thing. So we have military security and we also have economic security and we have human rights, and all of these things are interacting with climate change and they should be discussed at the highest level internationally and nationally. Climate litigation, as I mentioned, is probably a very effective way of slowing down emissions because we don't have world government. We desperately need a world parliament that can pass world laws which have to be enforced everywhere in the world. And because we don't have world democracy of that kind, we have to rely on international climate litigation. And that's probably going to happen much more frequently in the next 10 years. So I believe that that's the end of my talk, and I should just tell you that this is part of my climate tour and I'm actually going to Australia. And the reason why I'm in Belgrade is because it's on the way. And I have to go to Aktau in Kazakhstan, and then I have to go to Almaty, and I have to go to Urumqi in China. And if you happen to know someone in one of those places who would like me to give this talk, which is very unlikely, you could give me a personal contact because then I could give this talk to them. And that's the end of my talk. Thank you for your attention.
Thank you very much, Professor Parncutt. Yeah, I'm sure there was a question already. Alexander, raise your hands. So I have to say, it's very alarming.
It's very hard to talk in a calm and rational way about this topic, but this is what I encourage you to do. Yes.
Thank you very much for this very interesting lecture. And I have to admit that while you were speaking, I was constantly having more thoughts about the ideas that you were mentioning. And so that means that you will have to consider creating another tour that would make you stay here a little bit longer sometime soon in future. But I don't know where to begin. I was trying to write down the thoughts that I have. So when you were speaking about human value, how would you try to compare that with the attempts to put a price tag on human life? Can we, is value and price the same or not? Then as far as death, you were very critical about contemporary attitude towards death. But I have to stress that for social theory and philosophy, death is not a stranger because it's the ultimate existential experience that it's in its core egalitarian. So in that sense, this is something we really must discuss. In relation to that, also the notion of well-being from the point of commons, because you have this kind of almost a rule that when asymmetry in usage of resources appears, say you own a factory that is polluting the air, but I'm not, I'm just a citizen that is breathing the air, but you are actually using more air, and the risk of exploiting the entire air is the same. So it's not right, because there's asymmetry in our rights, in our access to resources. So the climate change is really the ultimate story about justice and rights. Then an interesting thing you mentioned is you just thought about the cars, the electric cars that have been bothering me for quite some time. Why we are not, I mean, I know the basic answer, why we are not using more cars that are actually running on methane when it's available? I mean, we have a obviously carbon dioxide emission from it, but what else could we do with all that methane? And generally, what do you think about electric cars in total vis-a-vis climate change? Because the way lithium is mining, because we really don't have the proper answer how to recycle lithium batteries that are being used, and etc. So thank you.
Great. Three questions, one very difficult, one bit easy.
So if I start with the cars, you were talking about burning methane, which is natural gas. Yes. But natural gas is just as bad. And natural gas is the bad thing about natural gas is that it causes climate change whether you burn it or not, right? So even if you don't burn it, it's going to cause climate change. And when you do burn it, it's more efficient than burning petrol, right? So it causes maybe 20% less or something, I don't know, but it's the same problem. And so obviously we have to stop doing that too. And of course electric cars are problematic, but it's not so bad as from the point of view right now of how much cars are contributing to climate change. One could perhaps calculate, using the methods that I showed, the number of people who are being killed by cars, conventional cars, as opposed to the number of being killed by electric cars. I think I would propose that as a possible answer. And I could guess that the answer would be that the number of people being killed by electric cars is considerably less, but of course is also still quite large, right? And so that would bring us back to the common opinion on this matter, which is that, yes, we have to convert cars to electric, and at the same time we have to improve public transport and encourage people to use their bicycles so that we have fewer cars, right? So both of those things at the same time, I think, is the standard answer to that question. Is that right? Of course, it's not easy, and all those people who own their big SUVs are going to have to get a shock, right? But I mean, the solution in that case is just to double the price of petrol so people can't afford to buy the fossil fuels in the first place. Anyway, so now what was the first thing you said? I have to remember this.
You know, that death is an egalitarian.
Oh yeah, death is egalitarian. That is so true. So it doesn't matter how many billions I have when I'm dying. Yes, but when we're dying, we're all equal and we're all alone, and we all face the paradox of death. And some people believe religious things and some don't, and all of this makes us equal in the end. Yes, but unfortunately, this doesn't solve our climate change problem. I don't think. You asked about evaluating the value of a human life, and
Can we put a tag on
yes. And I think politicians actually do have to do that, because it's unfortunately the case in politics that one has a certain amount of money in order to pay for medicine, right? For example, the medical bill, and a hospital has a certain amount of money and they have to do triage, which means deciding who's going to live and who's going to die. And so ultimately they are actually putting a value on human life. And so in many cases, it's a good idea to do it in a rational way, so at least it's transparent, right?
When we speak about price, it's not just the monetary price we can speak about, but also social one, security, economic price, you know.
Yeah, but
in that sense.
These are also dollars.
Yes.
Yes, and I'm trying to say in my talk that there's an inherent value of human life which is completely independent of anything economic, which we should put in the foreground. But we can also, in practical everyday situations, consider the economic value of someone's life, which is how much does it how much does it cost to save their life? How productive will they be in the economy from now until they die, right? Those are two completely different things. And economists, I'm happy with them if they calculate that. I just want them to say, in addition, there's this intrinsic value of human life, which is independent of economics. And we should put it on the top, I think. No?
Thanks. I would have also a couple of questions, of course, but maybe just to point out a few issues that are for me important. Okay. I would start from this assumption from one of the theorists, like Timothy Morton, who said that at the beginning of the Industrial Revolution, we already realized that this is the end of the world. That's a statement coming from the dark ecology. And first one would be a very simple question. Is it already too late? I mean, the scenario you presented, the climate changes, the pace of the climate changes, if we don't do anything about it, it's not just apocalyptic. All these United Nations gatherings, protocols, etc., they're contributing to nothing, because what is happening the priority of profit, not saving the lives. So particularly in case of extinction, as you mentioned, the worst case scenario. So is it already happening if we don't do anything about it, and who are we in terms of like doing anything about it, because the people, the haves will do something to have more, and the have-nots are in danger. And this is also the question of class and So maybe this is good. Really the first question: are we too late in a way?
Can I have the mouse back? So can I have this this device working again? Because I wanted to click through the slides. No. Not working? No? Oh, yes, it's working now. So, yes, in answer to this question, I wanted to go back over here somewhere. Where is it? Yeah. Yeah. You see, I'm assuming something like this graph, it just gets worse and worse. The longer we do nothing, the worse it gets. And that means that any point that we get to on this line, it is still worth trying to stop it. Now, trying to stop it might not get very far, but it's always possible to improve the situation of the next generation by reducing the current emissions. And no matter how bad it gets, I think we should do that. Another way of saying that is that the cost of climate action is always less than the cost of inaction. And you can calculate economically how much inaction will cost in the future and compare that to the cost of action now, and you will see that the future costs will always be worse. And therefore, there's no point ever giving up. Now, it's possible that it's already too late and the problem will never be solved, right? But that's only a probability, right? And we don't know how big it is. And therefore, I still think that it's worth fighting always for this. And no matter how bad it gets, that's how I see it.
Another thing that is very interesting for me, we are speaking a lot in the context of Belgrade and Serbia about air pollution. And I mean, we're facing false data. It's very difficult to make proper, let's say, analysis of the death toll caused by air pollution, because it averages. You can name different, let's say, organizations giving different data, but what comes as a surprise to me is and how to deal with this is what Rob Nixon calls slow violence. The pollution that goes into the air due to extractivism, then into the waters, and slowly kills people. So this is something that is really difficult to count and to measure, because this could be caused by different, let's say, cancers or etc., but after 20 years, maybe even. So this is also caused by the human, as you said, anthropogenic effect on the climate change. So how to measure all this? This is possible to include in some of the modeling that you presented?
Can I just add to it? As far as I know, yes, we do have terrible statistics and not lege artis properly monitoring of air pollution, but it's not that very important because you can actually monitor that via satellites. There is a possibility of objective assessment of air pollution in Serbia. So it's not, our authorities really cannot manipulate exclusively with their inaction vis-a-vis monitoring of air pollution. But that's what.
Yeah, I'm not actually very familiar with the exact methods of estimating the number of deaths from air pollution. But I think I've tried to show in this talk that there's a difference between bottom-up and top-down estimation, which means that it's possible to estimate the total number of deaths that are caused by burning fossil fuels approximately, and the approximate estimation is good enough to provide the political foundation and the legal foundation for actually solving the problem. So I don't have to go into all that detail. I read the literature and I take the opinions of people who know how that works more exactly. And I just basically believe them because I'm sure they're in the right order of magnitude, right? Plus or minus 30% or something like that. And also we have to remember that air pollution goes down, more global warming will happen. And it's also happening. It's happening already, partly because of shipping, right? So in the last few years, the international shipping has started to use less dirty carbon fuels. And apparently this is already having an effect on global warming, according to recent research by James Hansen in the United States. Of course, we have to stop the pollution, but we have to be prepared that there will also be negative consequences of stopping the pollution, right? And that's a really tricky thing, yeah.
Okay, thank you very much. I believe, time running, so we have to wrap it up.
Yep.
And thanks again for your inspiring talk. We have to think a lot about all the data you presented and to somehow process all this. So thanks again, and thank you.